Section 4.4. In this section, we're going to be solving radical equations. All right, so in your own word, write the meaning of the vocabulary term radical equation. Well, that's an equation that has at least one radical. I mean, you can just say it that way. It's going to be, most of the time, it's going to be an equation that has square roots where you're solving for a variable inside your square root. Or just feel free to say it's an equation that involves radicals. Extraneous solutions. Okay, these are solutions that you could get that turn out to actually not work when you go to check them. So what this is saying to us is that when you're solving radical equations, and they look like this. So let's say you got square root of x plus 4 equals 9. Okay, that's an example. When you solve these things for x, sometimes you're going to get values that don't check. So that's how you can describe an extraneous solution. It's where you solve for x, but it's a value that does not check. So we have to check our answers for all of these problems. For anytime we're solving these radical equations, we have to always make sure we're checking our answers. All right, the core concept, solving radical equations. To do that, you're going to follow these steps. The first is that you'll isolate your radical on one side of the equation, if necessary. It might already be on one side of the equation by itself. Step 2, raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. Step 3, solve the resulting equation using techniques you learned previously and check your answer. All right, so I'm going to go ahead and tell you. The reason that you don't see my face in this video is because these problems, especially when you get to one like number 8 where you've got two radicals, these are long. They are very long problems. And I do not have the whiteboard space to show one of these problems, so we're going to do it on paper. But don't be surprised if you get a question that you end up it takes a whole page and a half to get through the steps for it. So it's just that it's not to say that they're really that hard. They're just long. They have a lot of steps. Okay, so let's look at some of these. I'm not going to do I'm not going to do all of these. I'm going to try to go through and maybe do. I think I'll go through and do the odd problems. Is that going to be no? I'm just going to jump around. Maybe I'll do the evens. I may do the even problems with you, 2 through 10. So we're going to solve the equation, check our solution. And also, section 4.4 is designed to take 2 days, so there are going to be 2 videos for section 4.4. So this video would just be one day of it. All right, so this is, now again, you see me putting this on a separate sheet of paper, you need to be doing the same thing. Do not try to put all the steps to one of these problems on this page, or it's going to be a total mess. So this is section 4.4 notes. And we're going to do number 2. We're going to solve the cube root of 5x plus 1 equal negative 4. So the first thing I would want to do is cube both sides, with this being a cube root. So if I cube my cube root, it cancels out. I've got 5x plus 1. And then I'm going to cube negative 4. So I get 5x plus 1 equals negative, that's going to be negative 64. And then subtract 1 on both sides. So 5x equals negative 65. Divide both sides by 12. That gives me x equal negative 13. Then I check. So I'll have cube root 5 times negative 13 plus 1 equals negative 4. Cube root of negative 65 plus 1. That gives me the cube root of negative 64, and that does check. Oops, sorry about that. There. So that's my work for number 2. So our answer to number 2 was x equal negative 13, and it did check. All right, number 4. We've got 2 times the cube root of 13x minus 5 equals 10. So remember, going back to your steps, they said to first isolate your radical. So because I've got this 2 sitting out here, I need to do something about that 2. I can divide both sides by 2 to eliminate it. So that's going to give, so I'll divide here on both sides by 2. That gives me cube root of 13x minus 5 equals 5. And now I can cube both sides. So cube the cube root, that gives me 13x minus 5. Anytime that you square a square root or cube a cube root, the radical cancels out and the inside just pops out. So that's what's happening here. And then I need to cube the 5. So that gives me 13x minus 5 equals 125. I'm going to add 5 to both sides. That gives me 13x equals 130. Divide both sides by 13. I get x equals 10. And then I need to check it. So I'll have, and this is where I kind of goofed up. Go back to, did you see how I started manipulating the original equation? I should have rewritten it. But go back to the equation, the picture, or the problem on your paper. And we're going to check, we're going to substitute 10 in here for x. So doing that, I've got 2 times the cube root of 13, and we got 10 for x minus 5. We're going to see if that equals 10. So 2 times the cube root, just do order of operations, that's 130 minus 5, so that's 125 inside. And 2 times the cube root of 125 would be 5. So it does check. So my answer, x equal 10. All right, let's go on to number 6. So far I've only got one radical to deal with in each problem, so the steps are not that long so far. So you can cube both sides. You'll get 486 minus 27x cubed, because again the inside just pops out when I cube that radical. On the right side I need to cube 3x. So 486 minus 27x cubed equals 27x cubed. All right. And now we want to get x by itself, so I could add 27x cubed to both sides. I get 486 equals, that's going to give me 54x cubed. And then I can divide both sides by 54. Okay, does that go in evenly? Yes, it gives me 9 equals x cubed. So to solve for x, I want the cube root of 9. So I get cube root of 9 equals x. Can I do anything to simplify the cube root of 9? No, because it's 3 times 3, but I would need to have a factor 3 times for it to actually simplify. But I do need to check it. Okay, so we'll come over here to do our check work. So we're going to put cube root 9 into the original problem for the x. So we'll have cube root of 486 minus 27 times cube root 9, all under the radical, equals 3 times cube root 9. So I've got the cube root of 486 minus 27 times the cube root of 9. Let's see what happens if we go to the calculator with this. Let's see, to get your cube root, you go to Math 4, and you're going to put 9. So 27 times cube root 9. And then I want 486. Let's see, that was 56.16. I'm going to put an approximately equal. And then on the other side, I'm doing 3 times the cube root of 9. So Math 4. 3 times cube root 9 is 6.24. All right, and then I need to keep simplifying. So 486 minus 56.16. I've got cube root of 429.84, approximately equal to 6.24, and then take the cube root. So So I'm going to go math 4 for cube root, and then I can go second answer to get my 429.84 in there. That's giving me 7.5469. Of 486 minus 27 times x cube root 9 cubed. So it's telling us to cube x here, still all under the radical, equal 3 times x, so 3 times cube root 9. So this took up a lot of space here. All right, and then inside we're going to do, when I go inside my radical, notice I'm cubing my cube root. So the cube root of 9 cubed will give me 9. And then, so this gives me 9. And then I'm going to cube root of 486 minus 27 times 9 equals 3 times cube root 9. Okay, and then we can just go to the calculator. 486 minus 27 times 9. And then I want the cube root of that, so math 4, second answer, close parentheses. I get 6.24. On the right side, 3 times cube root of 9. So 3 times math 4, 9. Also gives me 6.24. So they do equal, so it does check. So the answer to number 6 was cube root of 9. All right, number 8. Okay, when I get to number 8, I'm seeing 2 radicals here. 2 radicals tells me this is going to be, you know what, this one's actually, I got lucky. This one's not going to be as bad because I've got a 0 over here, so it's not going to be so bad. Maybe number 10, yeah, number 10 is going to be a longer one. All right, but number 8, we've got 2 radicals, so don't be surprised if it gets a little long. So we've got square root 2x plus 2 minus 3 times the square root of x plus 1 equals 0. So I need to isolate a radical. I can do that if I add, I'm going to add 3 square root of x plus 1 to both sides. So that gives me the square root of 2x plus 2 equals 3 times the square root of x plus 1. And then to undo this radical, I want to square both sides. So if I square that, square my square root, and then do the same on the right. Square the square root, so the inside pops out, 2x plus 2 equals. And when I come over here, I have to make sure I remember that I'm squaring both the 3 and the radical. So 3 square gives me 9, and then square my square root, that gives me x plus 1. However, x plus 1 still needs to be multiplied to the 9, so I need to use parentheses for that part. And then I have 2x plus 2 equals 9x plus 9. I can subtract 2x on both sides. That gives me 2 equals 7x plus 9. Subtract 9 on both sides. I have negative 7 equals 7x. Divide both sides by 7. I'm getting x equals negative 1. Okay, now I'm not going to put my answer in a box because I have to check it. It might not be correct. So when I go to check it, I'm going to come down to the bottom of my page here. All right, here is my problem. So I'm going to put negative 1 into here for x. So I've got square root 2 times negative 1 plus 2, and then minus 3 times the square root of negative 1 plus 1 equals 0. Okay, so the square root of negative 2 plus 2, that's the square root of 0, minus 3 times, and then that's also the square root of 0. So this one checks. So my answer is x equal negative 1. So that one wasn't so bad. Okay, so in this one, we already have a radical isolated. Square root of 3 minus x is already isolated, so we can square both sides now. But be careful, when you square the left side, notice you've got two terms. You've got the square root of x plus 7, and you've got the 2. When you square that, you've got to think about what it means to square a binomial. So we're going to square the left, square the right. Okay. On the right side, you square your square root, the radical cancels out, and the 3 minus x just pops out. So we can put that now. On the left side, you're squaring a binomial, so you have to actually expand it out. When you square something, you're multiplying it by itself. So you're going to do the square root of x plus 7 plus 2 times itself. Square root of x plus 7 plus 2. Again, be careful with these radicals. Make sure that the correct things are on the inside of them. Okay. So the left side, we actually need to FOIL. So the first terms multiplied together. Square root of x plus 7 times the square root of x plus 7. Well, you're squaring a square root when you do that. So that's just going to give you x plus 7. The outer terms is going to be 2 times the square root of x plus 7. The inner terms will give me 2 times the square root of x plus 7. And the last terms will give me 2 times 2, so that's 4. And that's all equal to 3 minus x. Off the page over here. Now we've got to simplify this. So on the left side of the equation, what like terms do I have? 2 times the square root of x plus 7, 2 times the square root of x plus 7. Those are like terms, so we can combine those. Also 7 and 4, I can combine those. So we've got x plus 7 and 4 is 11. And then these two added together give me 4 times the square root of x plus 7, all equal to 3 minus x. Remember, we're working toward getting the second radical isolated on one side. So I could now maybe subtract x on both sides. And also, so we'll do that first. So that'll give me 11 plus 4 times the square root of x plus 7 equals 3 minus 2x. And I'll subtract 11 on both sides. So we've got 4 times the square root of x plus 7 equals negative 8 minus 2x. Okay. Now at this point, I know they said to isolate the radical, but we're close enough because you've got this 4 sitting out here. At this point, it's okay to square both sides. Just remember to square the 4 and square the radical. Because if you truly isolate the radical, you would need to divide both sides by 4 and you'd end up with a fraction, so you might not want to have to deal with that here. So I'm going to square both sides now. I'm going to square the 4 first, that gives me 16. And then I'm going to square my radical, that gives the x plus 7, and it has to be in parentheses. On the right side, I've got a binomial, so that needs to be FOIL. I need to expand that out so I can FOIL it. That's going to be 16x plus 112 equals, and then you FOIL, that's going to be 64. The outer is going to give you plus 16x. Inner is plus 16x. And then the last will be plus 4x squared. Okay. Now, on the right side, I can combine like terms. So I get 64 plus 32x plus 4x squared. I can now subtract 16x on both sides. So I've got 112 equals 64 plus 16x plus 4x squared. And because it's a quadratic equation, I want to set it to 0 and see if I can get it to factor. So let's subtract 112 on both sides. We'll get 0 equals negative 48 plus 16x plus 4x squared. All right, I want that in standard form, so I would write 0 equals 4x squared plus 16x minus 48. Looks like I can factor a 4 out, so that leaves me with x squared plus 4x minus 12. And then I can factor that, 2 times 6, and make it so 4 times x minus 2 times x plus 6. So use the zero factor property. That means 0 equals x minus 2, or 0 equals x plus 6. So 2 equals x, or negative 6 equals x. Okay, but don't put it in a box because you have to check it. Okay, so the original problem was right here, x plus square root of x plus 7. So I'm going to check 2 first. So square root of 2 plus 7 plus 2 equals the square root of 3 minus 2. So that's square root of 9 plus 2 equals the square root of 1. That's 3 plus 2 is 5. So 5 does not equal 1, so 2 does not check. Okay. Now check negative 6. So we'll have square root of negative 6 plus 7, and then the plus 2 outside equals the square root of 3 minus negative 6. It gives me square root of 1 plus 2 equals the square root of 3 plus 6, which is 9. Square root of 1 is 1, so I've got 1 plus 2 equals 3. This time it is checking. So my answer to number 10 is x equal negative 6. All right, and that's it. Thank you.